Okay, sir and madam, shall we start now? Basically, today
Yes,
class is the revision of yesterday's class. So we'll start with utility maximization problem. From the very name suggests that here in this problem, the consumer is there. His objective is he or she is maximizing the utility, and the utility function is represented by the function u function. Here, this u function is the utility function that depends on the quantity consumed of first good and second good. In this is the objective function. My objective, the consumer's objective is to maximize this utility function. Here x1, x2 are the arguments of this function. In short, we have to find out the values of arguments with x1, x2, that for which value the function will be maximized. But here, this is not a plain maximization problem. It is a constraint maximization problem. That means the consumer have to maximize utility, but he has to within the limit of its constraint area. Here, the constraint is this equation, otherwise known as the budget line. For a consumer, its budget line is this constant, or this budget line talks about basically this equation says left side, this side, P1 into X1 plus P2 into X2. This is the total expenditure. The first term P1 X1 is the total expenditure on first commodity, and this P2 X2 is the total expenditure on second commodity. So sum of P1 X1 plus P2 X2 indicates is the consumer's total expenditure. His total expenditure actually should be less than equal to M. General problem is to maximize my utility, the objective constant is my expenditure should not exceed my money income. So in that condition, my subjective constant will be P1 x1 plus P2 x2 should be less than or equal to M. But for mathematical application, we convert this inequality into equality. That means we have to, when we draw the equation, this subject to constant or this budget line will be represented by a straight line. Suppose this is the straight line. This is P1 x1. This is the P1 x1 plus P2 x2 is equal to M. So my constant area is not on this line only. This is on this, either the constant is the consumer have to either on this line or below this line, any point within this triangle, on this triangle or within this triangle. The expenditure in this area will be P1 into x1 plus P2 x2 will be either less than or maximum equal to M. This is my constant area. Consumer can move within this range, this triangle range. So now his objective is among these points, he has to choose that point which will be help him to be on the maximum possible indifference curve. If I draw the indifference curve, suppose given the preference, I am drawing the indifference curve. Here, three indifference curve are drawn. This is I21, IC2, IC3. Here, we can clearly see that the this IC1 indifference curve can be achieved within this income limit, because the points on this indifference curve are within our feasible region or within our constraint region. But the question is, should the consumer will be consuming at this point? No, because there's a possibility for the consumer to jump to higher indifference curve, that is IC2, where it can be within its budget constant, and that point will be this point E. When the consumer consumes at higher indifference curve IC2 on point E, which is my budget within the budget constraint. So this point is within the budget constant, and this is giving me more utility than IC1. So it's better for the consumer not to settle at the royal indifference curve, that is IC1, rather to shift to IC2. So that is giving me maximum utility. Now the question arises, if I move to IC3, I'll be getting more utility. So why the consumer will be at point E? Because no doubt IC3 is giving me more utility. But this within this constraint zone, the consumer cannot jump to IC3, because IC3 requires any point on IC3 requires more income. His expenditure will exceed the income. So this is not possible. The consumer cannot exceed its budget limit. Hence, the consumer cannot move to IC3. The maximum utility will be achieved when the consumer is at point E on the indifference curve IC2. Here, this point E, the solution. The solution indicates this X1 star amount of first commodity and the X2 star amount of second commodity. The argument X1, X2, its value will be this X1 star and X2 star. If the consumer consumes this unit of commodity, the utility will derive with the maximum utility, provided the consumer is within the budget constraint. So this point, E point, is the solution. This solution will be interior solution because at this point E, the consumer is consuming positive amount of each commodity. That's why this is the interior solution. So what will be corner solution? Another type of solution is known as corner solution. Like a point will be called a corner solution if just a minute, 2 minutes. Oh, sorry for the disturbance. What is it? We are talking about corner solution. What is a corner solution? A point or a combination of bundles will be known as a corner solution if in that bundle some commodity is consumed in positive quantity and some commodity are consumed with zero quantity, means that some commodity are not at all consumed. That point or that bundle will be called a corner solution. In this case, if the consumer is at point B, this point B is within the budget constraint, but here he is consuming no amount of zero amount of first commodity and this amount, some positive amount of second commodity. Similarly, at point L, this is L point, consumer is consuming some positive amount of first commodity and zero amount of second commodity. That's why this BL, or maybe this origin point where no amount is consumed, either commodity 1 or commodity 2 is consumed. Look, this 0, 0 point will also be a feasible point. Why? At point 0, 0, expenditure is 0, which is less than equal to M. This origin is a feasible point. And if some arbitrary situation, suppose this is the optimum point, then it will be a corner solution. So here we have many corner solution on this line or on this line or at these 2 points or this origin points. That will be the corner solution. Except that all other solutions are interior solution because each point we are consuming some positive amount of each commodity. Now we're done with the solution point. Now, the consumer in this problem, suppose given my prices is given as P1, P2, and M. Given the set of prices, the consumer when solve this optimum utility maximization problem, he is getting the solution as solution is X1 star and X2 star. Yeah. So that means if I link this P1, P2, M, this set with this X1 and X2, we can say we are getting a point on a demand curve. That means given the at this price, the consumer is consuming X1 star, X2 star. Similarly, if I make changes to this utility maximization problem, and my new price will be P1 dash, and new price will be P2 dash, and money income suppose given a, I'll solve the utility maximization problem. Definitely, as prices are changing, my budget constraint will change. This budget BL line will change. Accordingly, I'll get new solution. Let I am getting X1 dash solution, X2 dash solution. So this combination will be another point on the demand curve. That means given price P1 dash, P2 dash, and then the consumer will demand or choose this X1 dash, X2 dash bundle. So in short, the solution of the utility maximization problem will be giving me a demand curve. Demand curve means given this set of prices and income, the consumer will consuming this amount of commodity. That is demand. All the possible solutions of the utility maximization problem will automatically give me a demand function for different prices, different equilibrium, different solution, and that is the demand function. This type of demand function is known as Marshallian demand function. And this is developed by Marshall, as very name suggests. The Marshallian demand function is represented by this symbol X star, that is equal to X star depends on P1, P2, and M. So basically, we will say the solution to utility maximization problem will give us the Marshallian demand function. There will be another type of demand function which is known as Hicks demand function. That will derive from expenditure minimization problem. That is here in this slide. I'll later section I'll teach you that. Okay. I'm leaving this side. This is pass okay. Go to next one. Interior solution is one thing is here. While solving this utility maximization problem, where I may get a unique solution or I may get a more solutions, more than one solutions. So in which condition I'll be getting a unique solution, and in which condition I'll be getting a multiple solution. Yeah, I'm drawing it. As condition, suppose given my okay, no, let me draw. Okay, here given my budget constraint, I draw my budget line. Now, my indifference curve will completely depends on the preference of the consumer. If I assume that my consumer preference are convex preference. Remember, I am telling that it is a convex preference. I am not saying it is a strict convex function. Simply, it is a convex function. If it is a convex function, the indifference curve may look like this. This part is straight line part means this function is convex. It's a convex indifference curve. That means some portion of the curve has a straight line segment. That is from this point A, suppose A to C. This portion of the indifference curve will be a straight line. In this condition, the tangency of curve between the budget line and indifference curve more than 1 point. The all points will be the solution point, because it's a property of consumer maximization problem that the solution will occur at that point where the slope of the budget line is equal to slope of the indifference curve. Here, the tangency occurs at these multiple points. In that condition, for this price P1 and P2 and money income M, any such point will be my equilibrium point. In this condition, what I am getting? Given the price, I am getting more than one demand quantities. In that condition, demand will not be a function. We say it is what we call a demand, not demand function. We call it for a demand mapping. Call it a mapping. So the solution is not unique. It is clear. Why? Because my indifference curve is convex. And why my indifference curve is convex? Because the consumer preference are convex. Or in other languages, we can say the utility function will be quasi-concave. That's it. So I am getting multiple solution when the preference is convex, but not strictly convex. Strictly convex. If it is strictly convex, in that condition, I will be getting a unique solution, because in that condition, my indifference curve will be look like this. This is my budget line. There will be no line segment on the indifference curve. I see one. Here, the unique solution will be the solution. The consumer attains optimization at this one point. Sorry, my indifference curve is above it. Let me draw it correctly. Here, this will be like this. In this condition, it's a budget line and my indifference curve. Just tangency between my IC and budget line will be at a unique point. If the tangent is at unique point, so solution will be unique. Let's remember, if the preference are strictly convex, or someone may ask you, if the utility function is strictly quasi-concave, then the solution will be a unique solution or multiple solution. The answer is unique solution. If the question changes to, if the consumer preference is simply convex, or the utility function is quasi-concave, is there any possibility of getting multiple solutions? Statement is true. There is a possibility. if tangency occurs at the line segment. If tangency occurs not on the line segment rather than other parts, then in spite of having simply convex preference, I may get unique solution. So that's why I'm saying that it is a possibility of getting multiple solutions. Okay. Is this clear? Sir, madam, it is clear है लगी?
Yes, ma'am. Yes, ma'am.
କେତେବେଳେ
Yes,
ମୁଁ
ma'am.
unique solution ପାଇବି ଆଉ କେତେବେଳେ multiple solution ପାଇବି? Simply ତା preference ହିଁ determine କରିବ। ଯେମିତି consumer of preference, solution ସେମିତି ହବ। तो ମୁଁ next page को ଯାଉଛି। Okay. Continuous solution. Lagrange method. এটা ତ graphical solution ଆମେ କାଢିକି ଦେଖିଲେ। ଆମେ Lagrangian method use କଲେ ଆମେ ଯଦି କହିବା ପାଇବା କି କାହିଁକି maximization optimization occurs at the tangency point, ଆମେ ଯଦି math ର derivative formula ଟା use କରିବା। ତ Lagrangian method ବେସିକାଲି ସେଇଠି ୟୁଜ କରାଯାଏ ଯେତେବେଳେ କୌଣସି ଫଙ୍କସନ କୁ ମୁଁ ଅପ୍ଟିମାଇଜ କରିବି ସବଜେକ୍ଟ ଟୁ କିଛି କନଷ୍ଟ୍ରେଣ୍ଟ ଥାଏ। ପ୍ଲେନ୍ ଅପ୍ଟିମାଇଜେସନ ରେ ଯୋଉଠି କେବଳ ଫଙ୍କସନ କୁ ଅପ୍ଟିମାଇଜ କରାଯାଏ କିଛି କନଷ୍ଟ୍ରେଣ୍ଟ ନାହିଁ, ଦେୟାର ସିମ୍ପଲି ମୁଁ ଡେରିଭେଟିଭ ୟୁଜ କରିବି। ବଟ୍ ଯଦି ମୋର ଫଙ୍କସନ କୁ ଗୋଟେ କନଷ୍ଟ୍ରେଣ୍ଟ ସହିତ ଆଖି ଆଗ ରଖି ଅପ୍ଟିମାଇଜ କରିବି, ଦେୟାର ଆଇ ହାଭ୍ ଟୁ ୟୁଜ Lagrangian method। So what is in the Lagrangian method? First we have to set up the Lagrangian function. What is the Lagrangian function? A function that combines my objective function with its subjective constraint. That function is called a Lagrangian function. Here, this L is my Lagrangian function. This L, this is Lagrangian equation. Sorry, not function. Sorry. Here, in Lagrangian function, ux1, x2, this utility is my objective function, and this m minus p1, x1 minus p2, x2, it is my budget constraint. I am combining these two, objective and constant, by this lambda. Using this lambda, I am combining my utility objective function with the constant. That's why lambda is known as Lagrangian multiplier. In every kind of specific question, optimization problem, lambda will have its own interpretation. We'll deal with that later. Here. So one thing remember here, when I say plus lambda, the budget constant should be written in this way. First, my constant term, then take all the variables. Like what is my, in this condition, I'm writing here. So my budget constant equation is like this. This P1 x1 plus P2 x2 equal to m. This is my constant. If I write this plus sign, plus lambda, then what, after that I have to take all my equation towards the that side where my constant term is here. That means here in the left side, the right side. It should be write m minus P1 x1 minus P2 x2. Because I'm writing plus lambda. If I write minus lambda, so there we write minus lambda into take all towards left side, P1 x1 plus P2 x2 minus m. So depending plus lambda or minus lambda, accordingly तुम आपण माने साइन गुडा को डिटरमाइन करिवे। क्लियर? तो वंस Lagrangian फंक्शन हमें सेट कर देले, हमें सिंपली हम पळेबा फर्स्ट ऑर्डर कंडीशन को। एटा गोटे प्लेन फंक्शन को जेमते ऑप्टिमाइज करा जाय, एबे Lagrangian फंक्शन को ऑप्टिमाइज करबा। ए Lagrangian फंक्शन को ऑप्टिमाइज करले मोर ऑब्जेक्टिव फंक्शन ऑप्टिमाइज हो सब्जेक्ट टू कंस्ट्रेंट्स विद इन कंस्ट्रेंट जोन रे रही। तो फर्स्ट ऑर्डर कंडीशन सब बेले कहूची टेक ऑल द फर्स्ट ऑर्डर डेरिवेटिव इक्वल टू 0। एबे क्वेश्चन एटी केतेटा फर्स्ट ऑर्डर डेरिवेटिव आसीबो, दैट डिपेंड्स ऑन Lagrange फंक्शन रे केतेटा वेरिएबल अछि। So here this is the Lagrange equation. How many variable is there? One is x1, x2 and lambda. So I'll be taking three partial derivative. First set partial derivative of L with respect to x1, then with respect to x2, then with respect to lambda. Then set all the equation equal to 0. Here in the first two equation, solving it, I'll get mu1 from the first equation. This del L with respect to x1 equal to 0, it will giving me mu1 equal to lambda p1. Similarly, the second equation, that is del L with respect to x2 equal to 0, that will giving me mu2 equal to lambda p2. So last equation del L with respect to lambda, put it equal to 0, it will give my budget constant, simply the budget constant. So this explains that at the point of optimization, my budget constant is satisfied. Clear. So now what will I do from this equation? Let me write this equation as this is equation number 1 and this is equation number 2. Two equation, just divide equation 1 with equation 2. What I will be getting? I will be getting mu1 by mu2 is equal to lambda p1 by lambda p2. This lambda cancel out. Ultimately, I will get mu1 by mu2 is equal to p1 by p2. So what is mu1 by mu2? This is nothing but marginal rate of substitution of first for second commodity. MRS 1 for 2. And this P1 by P2 is the slope of, is nothing but the slope of budget line. And this MRS is the slope of IC, indifference curve. At the equilibrium point, this Lagrange method tells me that the slope of my budget line should be equal to slope of my indifference curve. And that occurs only at tangency point. At tangency point, both the slope are equal. So this Lagrangian method solve the question. The consumer obtains its equilibrium or maximizes its utility where the indifference curve slope and the budget line slope are equal. This is done. Then go to next stage. Yeah. Okay. This P1 by P2. A condition otherwise ଆମେ ଲେଖିପାରିବା mu1 by p1 equal to mu2 by p2. So basically କଣ କହୁଛି, what is this mu1 by p1 talking about? This mu1 by p1. This is when I spend p1 amount on purchasing the first commodity, I'm getting utility mu1. If I spend 1 rupee on purchasing first commodity, how much utility I will be getting? That is mu1 by p1. This side, this simply explains the return of 1 rupee from first commodity. Similarly, this side explains the return of 1 rupee from second commodity. So all this should be equal. That means return of 1 rupee from all commodities should be equal. Then only the consumer will be at equilibrium point. So this is equal to finally, this point is not also solving it. I'll be getting this is equal to lambda. This is the value of lambda. What is lambda? Lambda is the value of 1 rupee or marginal utility of 1 rupee. The lambda is interpreted in this way. Lambda is the marginal utility of 1 rupees. Clear. Now it is clear that the optimization equality will be maintained here. Now question arises, what happens if these ratios are not equal? Maybe left side is greater or maybe right side is greater. So what will happen then? Then let me go. Let me go to next slide. Here, this economic interpretation I have already done here. So I think, oh no, let me explain it in details. Okay, here. What is mu1 by mu2? This mu1 by mu2. What is this? This is the marginal rate of substitution. It is completely from the perspective of the consumer. Market has nothing to do with mu1 by mu2. Only consumer will explain it. What is mu1 by mu2 for the consumer? Here for the consumer, this mu1 by mu2, also otherwise known as marginal rate of substitution first for second commodity. So what this MRS explains? This explains that if a consumer increases 1 unit of first commodity, then he will reduce 2 units of second commodity. That means he'll trade 1 unit of first commodity with 2 units. How many units of second commodity? If I say the value of MRS, this MRS 142 is equal to 3. That means how the consumer will be trading between these two commodity. 1 unit of first commodity will be traded for 3 units of second commodity. This is the trading position of the consumer because MRS 142 equal to 3. That means if I increase 1 unit of first commodity, then I have to reduce 3 units of second commodity. So this is the exchange rate for the consumer. This is strictly from the point of view of consumer. The left side is talking about how the consumer is ready to trade. Now look at this right side. This side, P1 by P2. This side completely talks about the market view, how the market is trading. If I say P1, this P1 divided by P2 is equal to what is it? Let it is equal to, before that, let me price of first commodity equal to let's say 10 rupees and price of second commodity is equal to 5 rupees. In that condition, how the market will trade? Definitely, the market will trade or exchange 2 units of second commodity for 1 unit of first commodity, because 1 unit of first commodity is price equal to 10 rupees and 2 units of second commodity will give me 10 rupees. So this is how the market is ready to trade. So the market is ready to give up 2 units of second commodity for additional units of first commodity. This P1 by P2 simply explains how the market is ready to trade or exchange to commodity. And the left side explains how the consumer is ready to trade between two commodity. Equilibrium occur if equality is maintained at both sides. In our this example, here I write the values are like this. Okay, let me write down the values again so that we can easily write. Here, in our example, let our mu1 by mu2 is equal to 3. Or 3 or simply 3 by 1. You can write anything. And P1 by P2 is equal to 2. That means this 3 explains the consumer, in order to get 1 unit of first commodity, the consumer says, I'm ready to sacrifice 3 units of second commodity. Right? What market is explaining here. Here, P1 by P2 equal to 2. That means if it explains, if the consumer is give off or ready to take additional 1 unit of first commodity, then how much of second commodity is ready to the market? Means if he purchase 1 unit of first commodity, he have to pay 10 rupees extra. So how much a unit of second commodity he should give up so that the 10 rupee will be balanced here. The first commodity price is 10 rupees, second commodity price is 5 rupees. So you have to spend additional 10 rupees for purchasing 1 unit of X. So you have to give up 2 units of second commodity so that you will be a balance of 10 rupees. So there will be, in that concept, what's happening? The trade is possible. Suppose, let me explain କରୁଛି कि ମୁଁ ଗୋଟେ ଆମାଉଣ୍ଟ କିଛି କମୋଡିଟି କିଣିକି ରଖିଦେଇଛି, x1 କିଛି କିଣିଛି, x2 କିଛି କିଣିଛି। ଏବେ ମୁଁ କଣ ଚାହୁଁଛି, ଗୋଟେ ଏକ୍ସଟ୍ରା ୟୁନିଟ ଫାଷ୍ଟ କମୋଡିଟି କିଣିବି, ତ 10 rupees କନଜ୍ୟୁମର ମତେ ଦେବାକୁ ପଡିବ ସେଲରକୁ। ମୋ ପାଖରେ 10 rupees ନାହିଁ, ମୁଁ ତା ଏଗେନ୍ଷ୍ଟରେ କଣ କରିପାରିବି ନା କନଜ୍ୟୁମର କହିବି, ୟୁ ଟେକ୍ 2 commodity x2 from me। ତ ଫାଷ୍ଟ କମୋଡିଟି ଗୋଟେ ୟୁନିଟ ସେକେଣ୍ଡ କମୋଡିଟି 5 ଟଙ୍କା ହେଲା, ତ ଦିଟା ୟୁନିଟ 10 ଟଙ୍କା ହେଇଯିବ। ତ ମୁଁ ଗୋଟେ କାମ କରୁଛି, 10 ଟଙ୍କା ଦେଇପାରିବିନି, ୟୁ ଡୁ ୱାନ୍ ଥିଙ୍ଗ, ଗୋଟେ ୟୁନିଟ ଫାଷ୍ଟ କମୋଡିଟି ମତେ ଦେଇଦିଅ, ତା ବଦଳରେ ଦିଟା ୟୁନିଟ ଅଫ ସେକେଣ୍ଡ କମୋଡିଟି ମୋ ହାତରୁ ନେଇଯାଅ, ଟ୍ରେଡ ହେଇଗଲା। Clear? This P1 by P2 explains that is equal to, I hope this P1 by P2 is understood. Sir, madam, ନା ଏଟା ଟିକେ ମତେ explain କରିବାକୁ ପଡିବ ଆଉ।
ଆଉ ଟିକେ ମ୍ୟାମ୍ ଟିକେ
ଶୁଣନ୍ତୁ, ମନେକର ଏ ଜିନିଷ ମନେ ରଖନ୍ତୁ କି ପ୍ରାଇସ୍ ଅଫ ଏ ଏକ୍ସାମ୍ପଲ ମୁଁ ଏଟା ଆଜିମ୍ କରୁଛି ସ୍ପେସିଫିକ ଟୁ ଦିସ୍ ଏକ୍ସାମ୍ପଲ, P1 ର ପ୍ରାଇସ୍ ହଉଛି 10 rupees, P2 ର ପ୍ରାଇସ୍ ହଉଛି 5 rupees ହେଲା। ତ ସପୋଜ ମୋ ପାଖରେ କିଛି ଆମାଉଣ୍ଟ ର ଫାର୍ଷ୍ଟ କମୋଡିଟି ସେକେଣ୍ଡ କମୋଡିଟି ଅଛି। ଏବେ ସେଇ ଆଉ କିଛି ପଇସା ନାହିଁ ନା, ମୁଁ କନଜ୍ୟୁମର ସହିତ କଣ କରିବି, ସେ ଯୋଉ x1 ଆଉ x2 ର କ୍ୱାଣ୍ଟିଟି କିଛି ଚେଞ୍ଜ କରିବାକୁ ଚାହୁଁଛି। ଲେଟ୍ ମୁଁ କନଜ୍ୟୁମର ଯୋଉ ମାର୍କେଟ ସେଲରକୁ କହିବି କି ମତେ ଗୋଟେ ଏକ୍ସଟ୍ରା ୟୁନିଟ ଅଫ ଫାର୍ଷ୍ଟ କମୋଡିଟି ଦରକାର ହେଲା। ତ ତା ପାଇଁ ମତେ ପେମେଣ୍ଟ 10 rupees କରିବାକୁ ପଡିବ। ତ ମୁଁ କଣ କରିବି, 10 rupee ପେମେଣ୍ଟ ନ କରିକି ମୋ ପାଖରେ ଯୋଉ ସେକେଣ୍ଡ କମୋଡିଟି ଅଛି, ମୁଁ ତାର ଦିଟା ୟୁନିଟ ସେଲରକୁ ଫେରେଇ ଦେବି। ତେଣୁ ଗୋଟେ ୟୁନିଟ ର ଦାମ 5 ଟଙ୍କା, ତ ଦିଟା ୟୁନିଟ ର ଦାମ ହେଇଗଲା 10 ଟଙ୍କା। ତ ଦିଟା ସେକେଣ୍ଡ କମୋଡିଟି ଦିଟା ୟୁନିଟ ତାକୁ ଦେଇଦେବି, ତା ପାଖରୁ ଗୋଟେ ୟୁନିଟ ର ଫାର୍ଷ୍ଟ କମୋଡିଟି ନେଇ ଆସିବି, ଏକା କଥା ହବ।
ଆଜ୍ଞା।
ଏଠି P1/P2 କରି କହୁଛି। କିନ୍ତୁ କଞ୍ଜ୍ୟୁମର ପାଖକୁ ଆମେ ଯଦି ଯିବା କହିବା କଞ୍ଜ୍ୟୁମର ଯଦି ଗୋଟେ ୟୁନିଟ ଅଫ x1 ନବୁ, ତତେ x1 ମୁଁ ଦେବି, କେତେ ୟୁନିଟ ଅଫ x2 ତୁ ସାକ୍ରିଫାଇସ କରିବୁ ସୋ ଦ୍ୟାଟ ତୁ କଣ କରିବୁ, ତୋର ୟୁଟିଲିଟି କିଛି ଚେଞ୍ଜ ହବନି। ସିଏ କହିବ ଠିକ ଅଛି, ଯଦି ଦୋକାନୀ ମତେ ଏକ୍ସଟ୍ରା ୟୁନିଟ ଅଫ ଫାର୍ଷ୍ଟ କମୋଡିଟି ଦଉଛି, ମୁଁ ତାକୁ 3 ୟୁନିଟ ଅଫ ସେକେଣ୍ଡ କମୋଡିଟି ଦେବା ପାଇଁ ରାଜି ଅଛି। କିନ୍ତୁ ମାର୍କେଟରେ ଟ୍ରେଡ କରିବା ପାଇଁ କେବଳ 2ଟା ୟୁନିଟ ଦେଇଦେଲେ ଟ୍ରେଡ ହେଇଯାଉଛି। ତ ଗୋଟେ ଏକ୍ସଟ୍ରା ୟୁନିଟ ତା ପାଖରେ ରହିଯାଉଛି କଞ୍ଜ୍ୟୁମର ପାଖରେ। କଞ୍ଜ୍ୟୁମର କହିବ ମୁଁ କାହିଁ ସେ ପଏଣ୍ଟରେ ରହିବି, ମୋ ପାଖରେ ତ ଆହୁରି ବେଟର ପୋଜିସନ ଅଛି, ମୁଁ ତାର ଟ୍ରେଡ କରିଦେବି, ଗୋଟେ ଏକ୍ସଟ୍ରା ୟୁନିଟ ଅଫ ଫାର୍ଷ୍ଟ କମୋଡିଟି କିଣିଦେବି, 2ଟା ୟୁନିଟ ଦୋକାନକୁ ଦେଇଦେଲି, ତ ମୋ ପଇସା ବାଲାନ୍ସ ହେଇଗଲା। ଏବେ ମୋ ପାଖରେ ଆହୁରି ଅଧିକ ୟୁଟିଲିଟି ରହିଲା, କାରଣ ଗୋଟେ ସେ ଏକ୍ସଟ୍ରା ଆଡିସନାଲ ଫାର୍ଷ୍ଟ କମୋଡିଟି ରହିଲା, ସେଇ ୟୁଟିଲିଟି ମୋ ପାଖରେ ଅଛି। ମୁଁ କଣ କରୁଛି, 2ଟା ତାକୁ ଦେଇଦେଲି ସେକେଣ୍ଡ କମୋଡିଟି ଦୋକାନୀକୁ, ଆଉ ଗୋଟେ ଏକ୍ସଟ୍ରା ୟୁନିଟ ଅଫ ସେକେଣ୍ଡ କମୋଡିଟି ମୋ ପାଖରେ ରହିଲା। ମୁଁ ବେଟର ୟୁଟିଲିଟି ପୋଜିସନରେ ଅଛି, ତ ମୁଁ ଏଠି ଟ୍ରେଡ କରିବି ନାହିଁ। କ୍ଲିୟର, କାରଣ ମୋର ୟୁଟିଲିଟି ବଢୁଛି ଏଠି। ତ ମୁଁ ଏଠି କଣ କରିବି, ମୁଁ ଆହୁରି ଆହୁରି କଣ କରିବି, ଫାର୍ଷ୍ଟ କମୋଡିଟିକୁ ପରଚେଜ କରିବି, କାରଣ ଫାର୍ଷ୍ଟ କମୋଡିଟିର ଭ୍ୟାଲ୍ୟୁ ଅଧିକ ନା ମୋ ପାଇଁ। କ୍ଲିୟର ନା? ଏଇଠୁ କାହିଁକି ଜାଣିପାରୁଛନ୍ତି ଫାର୍ଷ୍ଟ କମୋଡିଟିର ଭ୍ୟାଲ୍ୟୁ ମୋ ପାଇଁ ଅଧିକ ରହୁଛି, ଅଧିକ ଭ୍ୟାଲ୍ୟୁ କରୁଛି, କାରଣ ମାର୍କେଟ କହୁଛି ତୁ ଇଏ ଗୋଟେ କାମ କର, 2ଟା ୟୁନିଟ ଅଫ ସେକେଣ୍ଡ କମୋଡିଟି ଦେଇଦେଲେ ମୁଁ ତତେ ଗୋଟେ ୟୁନିଟ ଅଫ ଫାର୍ଷ୍ଟ କମୋଡିଟି ଦେବି। କିନ୍ତୁ କଞ୍ଜ୍ୟୁମର କହୁଛି ସେ ଗୋଟେ ୟୁନିଟ ଅଫ ଫାର୍ଷ୍ଟ କମୋଡିଟି ପାଇବା ପାଇକି ମତେ ଯାହା ୟୁଟିଲିଟି ମିଳିବ, ମୁଁ 3ଟା ୟୁନିଟ ସାକ୍ରିଫାଇସ କରିଦେଲେ ମତେ ସେତିକି ୟୁଟିଲିଟି ମିଳିବ। କିନ୍ତୁ ମାର୍କେଟ ତ ଓନ୍ଲି 2ଟା ୟୁଟିଲିଟି ନେଇଯିବ ନା ତାର ଟ୍ରେଡ କରିବା ପାଇଁ, ଆଉ ଗୋଟେ ୟୁନିଟ ତ ତା ପାଖରେ ବଳିଗଲା। ତ ମୋ ପାଖରେ ଆଫ୍ଟର ଟ୍ରେଡ କଲା ପରେ ସେଇ ୟୁଟିଲିଟି ପ୍ଲସ ଆଡିସନାଲ ଗୋଟେ ଫାର୍ଷ୍ଟ ୟୁନିଟ ଅଛି। ତ ମୁଁ ୟୁଟିଲିଟି ମୋର ବଢୁଛି ଯଦି ଟ୍ରେଡ କରେ। ତ କଞ୍ଜ୍ୟୁମର ଟ୍ରେଡ କରିବ, କେମିତି ଟ୍ରେଡ କରିବ ନା ଆଡିସନାଲ କଣ କରିବ, 1 ୟୁନିଟ କୁ ସେ କିଣିବ, ଫାର୍ଷ୍ଟ କମୋଡିଟି କନଜମ୍ପସନ ବଢିବାକୁ ଲାଗିବ। କ୍ଲିୟର ଚିନ୍ମୟ ମ୍ୟାଡାମ, ଏଇଟା ବୁଝିହେଲା ନା?
Yes, ma'am. Yes, ma'am.
ଯଦି ସେ ଆଡିସନାଲ ୟୁନିଟ ଫାର୍ଷ୍ଟ କମୋଡିଟି କିଣିବାକୁ ଲାଗିବ, ତ ଅଲ୍ଟିମେଟଲି ମାର୍ଜିନାଲ ୟୁଟିଲିଟି ରେ କଣ ହବ, ଯୋଉ ଫାର୍ଷ୍ଟ କମୋଡିଟି ୟୁଟିଲିଟି କମିବାକୁ ଲାଗିବ। ତ MU1 ଯଦି କମିଲା, ଅଲ୍ଟିମେଟଲି MU1/MU2 ରେସିଓ କମିବ, till equality is equal to MU1/MU2 equal to 2 ହେଇଯାଇଛି। 2 ହେଇଗଲା ପରେ କଞ୍ଜ୍ୟୁମର ଆଉ ଟ୍ରେଡ କରିବ ନାହିଁ। କାହିଁକି ଟ୍ରେଡ କରିବ ନାହିଁ, କାରଣ ଏବେ ନୂଆ କଣ୍ଡିସନରେ କଣ ହବ, କମିକି MU1/MU2 ଏଟା 2 ହେଇଯାଇଛି, ମୋର ଅଲରେଡି P1/P2 2 ଅଛି। ତ ମାର୍କେଟ କହୁଛି ଯଦି ଗୋଟେ ୟୁନିଟ ଫାର୍ଷ୍ଟ କମୋଡିଟି ନବ, ମତେ 2ଟା ୟୁନିଟ ସେକେଣ୍ଡ କମୋଡିଟି ଦେଇଦିଅ। ଆଉ କଞ୍ଜ୍ୟୁମର କହିବ ୟେସ୍, ଯଦି ଗୋଟେ ୟୁନିଟ ଏକ୍ସଟ୍ରା ପାଇବା ପାଇଁ ମୁଁ 2ଟା ଦେବା ପାଇଁ ରାଜି ଅଛି, ମୋର ୟୁଟିଲିଟି କିଛି ଚେଞ୍ଜ ହଉନାହିଁ। ଯଦି ୟୁଟିଲିଟି କିଛି ଚେଞ୍ଜ ହଉନାହିଁ, ମୁଁ ଟ୍ରେଡ କାହିଁ କରିବି, ସେଠି ଷ୍ଟେବଲ ରହିଯିବି। ତ ଦ୍ୟାଟ ୱିଲ୍ ବି ମାଇ ଇକ୍ୱିଲିବ୍ରିୟମ ପଏଣ୍ଟ। ଇକ୍ୱାଲିଟି ଯେପର୍ଯ୍ୟନ୍ତ ଆସିନି, ମୁଁ ଇକ୍ୱିଲିବ୍ରିୟମରେ ରହିବି ନାହିଁ। ଯଦି ମୋର MRS ଟା ଅଧିକ ହଉଛି P1/P2 ଅପେକ୍ଷା, ତ ମୁଁ ଅଧିକ ଅଧିକ 1 ୟୁନିଟ କୁ ପରଚେଜ କରିବି, ଫାର୍ଷ୍ଟ କମୋଡିଟି କୁ ପରଚେଜ କରିବି। ତ ସିମିଲାରଲି ଆପଣ ସେକେଣ୍ଡ କମୋଡିଟି ଯଦି MU1/MU2 ଲେସ୍ ଦ୍ୟାନ୍ ହେଇଥିବ P1/P2, ତ ସେମିତି ଇଣ୍ଟରପ୍ରିଟ କରିବେ କି ତା ପାଇଁ ସେକେଣ୍ଡ କମୋଡିଟିର ଭ୍ୟାଲୁ ଅଧିକ ଅଛି, ତ ସେ କଣ କରିବ, ସେକେଣ୍ଡ କନଜମ୍ପସନ ବଢିବାକୁ ଲାଗିବ। ତ ଜଷ୍ଟ ଏଠି ଯେମିତି ଇଣ୍ଟରପ୍ରିଟ କରାହେଲା, ସେଠି ବି ସେମିତି ଇଣ୍ଟରପ୍ରିଟ କରାଯିବ। ତ ଏଟାକୁ ମୁଁ ସ୍କିପ୍ ଛାଡି ଦଉଛି, ଆପଣ ଯୋଉ ଲେସ୍ ଦ୍ୟାନ୍ କଣ୍ଡିସନ ଟାକୁ ବି ଇଣ୍ଟରପ୍ରିଟ କରିପାରିବେ।
Yes.
ଏତିକି ଟ୍ରେଡ ପାଇଁ ମୁଖ୍ୟ ଜିନିଷ, କି କାହିଁକି ଟ୍ରେଡ ହଉଛି, କଣ ପାଇଁ ଇନଇକ୍ୱାଲିଟି ହେଲେ କଞ୍ଜ୍ୟୁମର ଟ୍ରେଡ କରିବା ପାଇଁ ରାଜି ହଉଛି, ଗ୍ରେଟର ଦ୍ୟାନ୍ ହେଲେ ଲେସ୍ ଦ୍ୟାନ୍ ହେଲେ କାହାକୁ କାହା ସହିତ ଟ୍ରେଡ କରୁଛି। ସେଇଟା ହେଉଛି ଏଠି ମେନ୍ ଥିମ୍ ଟା, ମେନ୍ ଅବଜେକ୍ଟିଭ ଟା। ଆଇ ହୋପ ଏଇଟା ହିଁ ବୁଝିବା ଦରକାର। ତ ଏଇଟାକୁ ପଳେଇଲା, ସେକେଣ୍ଡ ପାର୍ଟକୁ ଯିବା। ଓକେ, ଏଇଟା ତ ମୁଁ କହିଲି କାହିଁକି ଇକ୍ୱାଲିଟି ହଉଛି। ତ ଏଟା ଓଲଟା ରିଭର୍ସ ସାଇନ୍, ଯଦି ରିଭର୍ସ ସାଇନ୍ ଆସିବ, ଏଇ ଏଇ ଆଇ ଥିଙ୍କ ଏଇ ଆର ଅପୋଜିଟ ସାଇନ୍ ଟା, ଏଇଟା ମୁଁ ଏକ୍ସପ୍ଲେନ କଲି। ତ ରିଭର୍ସ ସାଇନ୍, ଏଇ ତଳ ସାଇନ୍ ଟା ଆପଣ ଆକର୍ଡିଂଲି ଏକ୍ସପ୍ଲେନ କରିବେ। ତାକୁ ମୁଁ ବି ସ୍କିପ୍ କରିଦଉଛି। ଏଇଟା ଇଣ୍ଟେରିୟର ଅପ୍ଟିମମ୍, କ୍ୟାରେକ୍ଟରିଷ୍ଟିକ୍ସ ଅଫ ଅପ୍ଟିମମ୍। ତ କହୁଛି ୟୁଟିଲିଟି ମାକ୍ସିମାଇଜେସନ ପ୍ରୋବ୍ଲେମ ର ସଲ୍ୟୁସନ ର କ୍ୟାରେକ୍ଟରିଷ୍ଟିକ କଣ ହବ, ଫାର୍ଷ୍ଟ କଣ ହବ, the consumer will attain optimum point or solution on the budget constraint. That means all his income will be spent, no income is left out. That means total expenditure should equal to consumer total income. Second, এটা পাইলে tangency, that means IC indifference curve is touches to budget line. This is the second property. And third property করা, the any other affordable point will definitely be on a lower indifference curve. আর যদি এনি আফোর্ডেবল পয়েন্ট যে হায়ার ইন্ডিফরেন্স কর্ভ ଅଛି, তো ডেফিনেটলি ସେଇ ପଏଣ୍ଟ ହିଁ ମୋର ସଲ୍ୟୁସନ ପଏଣ୍ଟ ହବ। These three are the basic properties. Second comes uniqueness. When the solution will be unique, the solution will be unique if and only if my preference are strictly convex, or otherwise I can say my utility function will be strictly quasi-concave. Any data point, strict convexity of preference kuhantu kimba strict quasi-concavity of sorry utility function kuhantu, both will lead to uniqueness of the solution. Okay. So ଏତିକି point ମନେ ଅଛି. Lambda interpretation. What is lambda here? Lambda is equal to mu y by py. It is nothing. The return I am getting, mu y by py simply explains by spending 1 rupee on ith commodity, how much utility I am getting. In short, lambda is the marginal utility of 1 rupee or money. Here, in this utility maximization problem, lambda is called as marginal utility of money. For other function, other utility functions, lambda value, its interpretation will be differ accordingly. Now, the formal statement is this lambda of b. What is b here? B is the indirect utility function. Now, question is what is the indirect utility function? We know about direct utility function. Now, there is another utility function. It is called as indirect utility function. Basically, direct utility function is represented by the term u. U is the utility function. And the utility depends on how much of the commodity, how much quantity of the commodity the consumer is consuming. The direct utility function simply depend କରୁଛି consumer କେତେ quantity ଅଛି. ସେଟା consumer କହିବ ମୋର utility ଏତିକି ପାଇଲି. କିନ୍ତୁ ଏଠି consumer rationality ଆଉ ଦେଖିବାକୁ ନାହିଁ. Simply consumer କୁ ପଚାରିଲେ you have this amount of commodity and you tell me what is your utility. Simple. କିନ୍ତୁ ଏଥିରେ ଆମେ ଇନଡାଇରେକ୍ଟ ୟୁଟିଲିଟି କହୁଛନ୍ତି କନଜ୍ୟୁମର ରେସନାଲିଟିକୁ ବି ଆମେ ଟେଷ୍ଟ କରୁଛନ୍ତି, କାରଣ ଆମେ ସେଠି ସିଧା କନଜ୍ୟୁମରକୁ ଏଇଟା ପଚାରିବା କନଜ୍ୟୁମର ଗିଭିଂ ଦ ପ୍ରାଇସେସ୍ P1, P2 and M ଏତିକି ଅଛି, ତ ତୁମେ କେତେ ୟୁଟିଲିଟି, ହାଉ ମଚ୍ ୟୁଟିଲିଟି ୱିଲ୍ ବି ଗେଟିଂ ଇଟ୍, ଦ୍ୟାଟ୍ ଇଜ କଲ୍ଡ ଦ୍ୟାଟ୍ ଇନଡାଇରେକ୍ଟ ୟୁଟିଲିଟି। ଏଠି କନଜ୍ୟୁମର କଣ କହିବ, କନଜ୍ୟୁମର ଭାବିବ କି ତା ରେସନାଲି ସେ ଥିଙ୍କ କରିବ ଦିସ୍ ଇଜ ଦ ମାର୍କେଟ କଣ୍ଡିସନ P1, P2 and M, ତ ଏଇ ମାର୍କେଟ କଣ୍ଡିସନରେ କୋଉ ବଣ୍ଡଲଟା ଚୁଜ୍ କରିବି ଯାହା ମତେ ସବୁଠୁ ଅପ୍ଟିମମ୍ ୟୁଟିଲିଟି ଦବ, ସେ ବଣ୍ଡଲକୁ ଡିସାଇଡ୍ କରିବ, ଦ୍ୟାଟ୍ ଇଜ ସପୋଜ X1 ଷ୍ଟାର X2 ଷ୍ଟାର, ତାପରେ କହିବ ଏଇ ବଣ୍ଡଲ ମତେ ଯାହା ୟୁଟିଲିଟି ମିଳିଲା ସିଏ ହଉଛି ମତେ ୟୁଟିଲିଟି କହିବ ଏଇ ସେଟ୍ ଅଫ ମାର୍କେଟ କଣ୍ଡିସନ ଏତିକି ୟୁଟିଲିଟି ମତେ ଦବ। ତ ଏଇ ଯୋଉ ମାର୍କେଟ କଣ୍ଡିସନ ମୁଁ ଯେତେ ୟୁଟିଲିଟି କୁ ଡିରାଇଭ୍ କରୁଛି ତ ଡେଫିନେଟଲି କନଜ୍ୟୁମର ରେସନାଲ ଥିଙ୍କିଂ କୁ ଆମେ ଜଜ୍ କରୁଛନ୍ତି କି ଆକ୍ଚୁଆଲି ରେ ସେ ଗିଭେନ୍ ପ୍ରାଇସେସ୍ ଆଣ୍ଡ ମନିରୁ ସେ ଏଇ ଅପ୍ଟିମାଲ ବଣ୍ଡଲ ଚୁଜ୍ କରୁଛି କି, ଅପ୍ଟିମାଲ ବଣ୍ଡଲ ଚୁଜ୍ କଲା ତାପରେ ଏଇ ବଣ୍ଡଲ ଯାହା ୟୁଟିଲିଟି ମିଳିଲା ସେଟା ହବ ତାର ଇନଡାଇରେକ୍ଟ ୟୁଟିଲିଟି। ଏବେ କ୍ୱେଶ୍ଚନ କି ଅଲୱେଜ ଡାଇରେକ୍ଟ ୟୁଟିଲିଟି ଇନଡାଇରେକ୍ଟ ୟୁଟିଲିଟି ସେମ୍ ୟୁଟିଲିଟି ଫଙ୍କସନ କୁ ରିପ୍ରେଜେଣ୍ଟ କରୁଛି କି? ମେ ବି ମେ ନଟ୍ ବି। ଯଦି consumer rational ହେଲା, if the consumer thinks rationally, that means given prices P1, P2, PM prices ସେ ସବୁବେଳେ ସେ optimum bundle କୁ ସେଇ bundle କୁ ଚୁଜ୍ କରେ ଯିଏ ସବୁଠୁ ଅଧିକ ୟୁଟିଲିଟି ଦିଏ, ତ ତାହେଲେ ମୁଁ କହିବି yes direct indirect utility ସେମ୍ ହବ। କିନ୍ତୁ ମନେକର given prices the consumer is not rational, ସେ ଆଉ କୋଉ bundle ଚୁଜ୍ କରୁଛି ତ ସେ bundle ଅଲଗା ୟୁଟିଲିଟି ଦଉଛି, ତେବେ direct utility indirect utility differ କରିବ। କ୍ଲିୟର? ଏଇଟା ମିଲି ସମଟାଇମ୍ସ ଯେତେବେଳେ ମୁଁ ଯାଇଥିଲି ଗୋଟେ ଜାଗାକୁ ଇଣ୍ଟରଭ୍ୟୁ ଦେବା ପାଇଁ ଯାଇଥିଲି, ମତେ ଡାଇରେକ୍ଟ ପଚାରିଲେ ହ୍ୱାଟ ଇଜ ଇନଡାଇରେକ୍ଟ ୟୁଟିଲିଟି ଫଙ୍କସନ, ମୁଁ ସିମ୍ପଲି କହିଦେଇଥିଲି ଇନଡାଇରେକ୍ଟ ୟୁଟିଲିଟି ଫଙ୍କସନ ଇଜ ଅ ଫଙ୍କସନାଲ ରିଲେସନସିପ ବିଟୱିନ ୟୁଟିଲିଟି ଡିରାଇଭ୍ and the prices and money income. That is not the sufficient answer. ତ ସେ ମତେ ଇଭିନ୍ ଏମିତି ଏକ୍ସପ୍ଲେନ କରିଥିଲେ ଦ୍ୟାଟ୍ ଇଜ ନଟ୍ ଦ ଆନ୍ସର, ତ କାହିଁକି କେଇ ରିଲେସନଟା ତ ଏକ୍ସପ୍ଲେନ କର ବୁଝେଇଲେ, ତ ଏକ୍ସପ୍ଲେନ ଆକ୍ଚୁଆଲି ଏମିତି କରାଯିବ। ଆଉ ଫ୍ୟାକ୍ଟଟା କଣ କହୁଛି, ଗିଭିନ୍ ସେଟ୍ ଅଫ ପ୍ରାଇସେସ୍ ଆଣ୍ଡ ମନି ଇନକମ୍ ଦେଇଛି, ଦେନ୍ କନଜ୍ୟୁମର ଏଇ ତା ରେସନାଲିଟି ୟୁଜ କରିକି ଅପ୍ଟିମମ୍ ବଣ୍ଡଲ ଚୁଜ୍ କରିବ, ଦେନ୍ ଅପ୍ଟିମମ୍ ବଣ୍ଡଲ ଯାହା ୟୁଟିଲିଟି ଦବ ସେ କହିବ ଏଇ ସେଟ୍ ଅଫ ପ୍ରାଇସ୍ ଆଉ ମନି ଇନକମ୍ ଏଇ ୟୁଟିଲିଟି ସହିତ ଆସୋସିଏଟେଡ୍, and this association is known as indirect utility function. Am I clear? अच्छा सर मैडम ये इनडायरेक्ट यूटिलिटी फंक्शन क्लियर है कि?
मैडम टे डेफिनेशन टा आउथरे कहबे कि?
Indirect utility function explain the utility the consumer will derive from the given set of prices and money income. That is indirect utility function. In this case, given the set of prices and money income, consumer will use utility optimization problem and choose that bundle which will be giving maximum utility. Now the bundle, the utility derived from that optimum bundle will be my indirect utility. ତାକୁ indirect utility ଆମେ କାହିଁ କହୁଛନ୍ତି? କାରଣ commodity prices money income କେବେ utility ଦଉନି। ଯେତେ direct utility commodity bundle ତାକୁ utility ଦଉଥିଲା। That's why ମୁଁ ତାକୁ direct utility କହିଲି। କିନ୍ତୁ ଏଠି ମୁଁ କଣ କରୁଛି, ଆଗ price ଆଉ money income ଅଛି, ତାକୁ ମୁଁ convert କରିବି commodity bundle କୁ, then commodity bundle ମତେ କେତେ utility ଦେଲା। ଇଏ ହଉଛି ଡାଇରେକ୍ଟ ଆଉ ଇନଡାଇରେକ୍ଟ ୟୁଟିଲିଟି ଫଙ୍କସନ। ତା ଡେଫିନେସନ ମୋର ଏକ୍ସାକ୍ଟ ଡେଫିନେସନ ମନେ ନାହିଁ, ତାକୁ ଏମିତି ନିଜ ଲାଙ୍ଗୁଏଜରେ ମୁଁ ତ ଏକ୍ସପ୍ଲେନ କରିକି କହିପାରିବି। ଡେଫିନେସନ ବି ଇନଫାକ୍ଟ ମ୍ୟାଟର କରୁନି, ଜଷ୍ଟ ଲେଖିବା କଥା ଆଉ।
ଆଜ୍ଞା ଆଜ୍ଞା ମ୍ୟାଡ଼ାମ ଠିକ ଅଛି ମ୍ୟାଡ଼ାମ। ଆଉ
ହେଇଗଲା।
ଅନ୍ୟମାନେ ବୁଝିପାରିଲେ କି ନାହିଁ ଯୋଉମାନେ ପଢୁଛନ୍ତି?
ଏଇଟା ତ କଥା, ଏଇଟା ବୁଝିପାରିଲେ କି ନାହିଁ?
ଚିନ୍ମୟୀ, what is indirect utility function?
Sir, indirect utility function कुछ भी
ମ୍ୟାଡାମ ତାକୁ ନିଜ ଲାଙ୍ଗୁଏଜରେ କୁହନ୍ତୁ, କେବେ ସେଇ ଡେଫିନେସନ କି ବୁକିସ୍ ଲାଙ୍ଗୁଏଜ କୁହନ୍ତୁନି। ଯେତେବେଳେ ଫାର୍ଷ୍ଟ ଟାଇମ ବୁଝୁଛନ୍ତି ନିଜ ଭାଷାରେ ପ୍ଲେନ ଲାଙ୍ଗୁଏଜରେ କହିଦିଅନ୍ତୁ। ଓକେ ସାର୍, ମୁଁ ଟିକେ ଏଠି ଆଉ ଥରେ ଟ୍ରାଏ କରୁଛି। ସପୋଜ ମତେ ଆଜି କିଏ ପଚାରିବ ହ୍ୱାଟ ଇଜ ଇନଡାଇରେକ୍ଟ ୟୁଟିଲିଟି ଫଙ୍କସନ, ମୁଁ ସିମ୍ପଲି ଏମିତି ଏକ୍ସପ୍ଲେନ କରିବି। Me as a consumer is giving me the prices and the money income. Using this information, I'll be determine which bundle I should choose that will give me maximum of utility. Now, the chosen bundle, the utility that I get from this chosen bundle will be the utility that I derive from my prices and money income set. The association between this utility and my prices and money income is known as indirect utility function. এটা ମୁଁ as a layman just ମୋର language ରେ basic language ରେ explain କଲି। ହଁ କିନ୍ତୁ ଏଇଟା ମୁଁ ଆଜ୍ୟୁମ କରୁଛି କି ଯେତେବେଳେ ତୁମେ ପୁରା ଇଏ ଅଛ, ପୁରା ସ୍ପେଶାଲିଷ୍ଟ ଲେବୁଲ ଆନ୍ସର ଦଉଛ, ତୁମେ ଡେଫିନେସନ ରେ ୟୁଜ କରିକି ଦେଇଦବ। ଏଇଟା ମୁଁ ଭାବେ ବୋଧେ ସାର୍, ଆମ୍ ନଟ୍ ସିଓର, ମେ ବି ମୁଁ ଭୁଲ ହେଇପାରେ, କିନ୍ତୁ ମତେ ଲାଗୁଛି ଏମିତି ଏକ୍ସପ୍ଲେନ କରିବାଟା ମେ ବି ଟିକେ ବେଟର ରହିବ ଇନିସିଆଲ ଷ୍ଟେଜରେ। ସାର୍
ଠିକ ଅଛି ମ୍ୟାଡ଼ାମ।
ତ ଚିନ୍ମୟ ମ୍ୟାଡାମ, ଆପଣଙ୍କୁ ଆଇ ଅଣ୍ଡରଷ୍ଟାଣ୍ଡ କି ଏଇଟା ଟିକେ କଷ୍ଟ ହେଇପାରେ ଟିକେ, ନିଜେ ଏଠି ବହିରେ ଯୋଉ ମାଟେରିଆଲ ଟିକେ ଦେଖନ୍ତୁ, ତାପରେ ଯଦି ଗୁଗୁଲରେ ଇନଡାଇରେକ୍ଟ ଫଙ୍କସନ କଣ ତାକୁ ଟିକେ ବାରମ୍ବାର ପଢନ୍ତୁ, କଲେଜ କନସେପ୍ଟ ଟା ପୁରା ମୁଣ୍ଡରେ ଫିଟ୍ ହେଇଯିବ। ଆଉ ମୁଁ
ଆଜ୍ଞା ମ୍ୟାମ୍।
ଜାଣିନି କେତେ ଆପଣଙ୍କୁ ହେଲ୍ପ କରିବ, ବଟ୍ ମୁଁ ଯେତେ ପାରୁଛି ମୁଁ ବୁଝେଇବାକୁ ଚେଷ୍ଟା କରୁଛି ଆଉ।
ଟିକେ ହଲ୍ ଭେରିଏଣ୍ଟ ଟିକେ ପଢିବାକୁ ପଡିବ।
ଆଜ୍ଞା ଆଜ୍ଞା, ଓକେ ସାର୍, ଆଗକୁ ଯିବି କି?
ଆଜ୍ଞା ମ୍ୟାଡ଼ାମ।
ଏଠି ତ ଫର୍ମାଲ ଷ୍ଟେଟମେଣ୍ଟ କହୁଛି, the first order partial derivative of indirect utility function with respect to m is equal to lambda. So what is this right hand side is explanation said that change, if money income is changed by one utility, then how much my indirect utility is uh, changing, that is the lambda. Given my prices P1 P2, suppose P1 P2 prices ଥିଲା, money income ଏତିକି ଥିଲା, ତ associated utility ଏତିକି ଥିଲା। ଏବେ ମୁଁ ପ୍ରାଇସେସ୍ ଗୁଡାକ ସେଇ ସେମ୍ ରଖିଲି, ଜଷ୍ଟ ମନି ଇନକମ ରେ ୱାନ୍ ୟୁନିଟ ଟା ଚେଞ୍ଜ କଲି, ସ୍ମଲେଷ୍ଟ ୟୁନିଟ ଟାକୁ ମୁଁ ଚେଞ୍ଜ କଲି, ତ ମୋ ୟୁଟିଲିଟି କିଛି ଚେଞ୍ଜ ହବ, ଦ୍ୟାଟ ଚେଞ୍ଜ ଇଜ ମାଇ ଲାମ୍ବଡା ଅର the utility that I am getting from one unit of money income, that is lambda. Clear? So I am going to, okay, then next ଯାଉଛି। okay, କର୍ଣ୍ଣର ସଲ୍ୟୁସନ। କର୍ଣ୍ଣର ସଲ୍ୟୁସନ କଣ ପ୍ରପର୍ଟିଜ ହେଇପାରେ ଦେଖିବା କଥା ଆଉ। as optimal bundle, simply explain କରୁଛି, କର୍ଣ୍ଣର ସଲ୍ୟୁସନ କଣ? occurs when optimal bundle has some xi which is equal to 0, that is my Corner solution. Corner solution, perfect substitute केतरे we are getting corner solution, and it is clear at corner point the slope of two, the budget line and indifference curve cannot be equal, because one price is extremely high, another commodity price is extremely low, so there is no comparison of ratios. That's why the equality cannot be maintained here. Simply, and the boundary of consumption set is non-negative constraint. I think এটা just মনে ରଖିଦେବା କହୁଛି, ଆକୁ ତାକୁ କିଛି ଏକ୍ସପ୍ଲେନ କରିବାକୁ ନାହିଁ। ଡିମାଣ୍ଡ ଫଙ୍କସନ କୁ ଆସିବା। ଡିମାଣ୍ଡ ଫଙ୍କସନ ଡେଫିନେସନ and properties. Demand function ଗୋଟେ କହିଥିଲି କଣ? Marshallian demand function. What is Marshallian demand function? It is the solution of the utility maximization problem. Marshallian demand function simply express, given the prices and money income, what is the optimal consumption bundle the consumer is choosing. That is the Marshallian demand function. And this notation is mentioned here, just remember it. Yes. This X is the bundle. It depends on the price. P1, P2 is the price vector, M is the money income. This bundle contains X1 star and X2 star. Each one, X1's demand depends on its price, relative commodity price is money income. Similarly, second commodity, how much it will be demanded depends on its prices of related commodity and money income. This is Marshallian demand function. So in this function, so what is the property? First property is it's homogeneous of degree 0. It means if all the arguments here in this function, demand function, the independent variables are otherwise sometimes called as arguments. Or you simply the in the demand function will be homogeneous of degree 0 if all its independent variables are increased by given amount, given proportionately increased, then there will be no effect on the demand. That means if all the prices and money income are doubled, still the demand will not change. It will double or triple or maybe half. All the prices are half and money income is also half. Then there will be no change in demand. Why? Because when that is property of budget line, that is if the prices of all the commodity increases by a given amount and the income also increases by same amount, then the budget line equation will not be changing. If the budget line equation is not changing, that means my budget constant is also not changing. As long as budget constant is not changing, given the individual preferences, the optimal point will not change. That's why we say Marshall demand function is homogeneous of degree 0. Why I am saying the budget equation? Let me write the budget equation here. That is equal to P1 x1 plus P2 x2 is equal to M. This is budget constant equation. Let multiply T with every term. So I'll be getting T into P1 x1 plus T into P2 x2 is equal to T into M. Okay. So here, what is happening? This is the new budget. Here, say the price become TP1 and TP2, money income become TM. So inside the first and second equation, both are same. In spite of increasing both prices and money income by a given multiplier time, there will be no change in budget constraint. So my optimal solution will not change at all. That's why my Marshallian demand function will be homogeneous of degree 0. Yeah. And delete it. Clear. Go to next test. This property is done. Second, Waller's law. What is Waller's law? Nice explain that. The consumption equilibrium point occurs at the budget line. That means all money income will be spent at the optimal point. Here at the optimal point, suppose we get X1 is our optimal bundle. This X1, let me write it here. I'm writing the Waller's statement here. खाली जगह मिल इतने कुछ P1 is my price. I'm choosing X1 star. This X1 star depends on P1, P2 and money income M. This is the expenditure on first commodity. When I choose the optimal bundle plus price of second commodity into second, this is the optimal bundle of second commodity. That depends on P1, P2 and M. This is equal to M. This is the expenditure. When I choose the optimal bundle, this optimal bundle requires expenditure, this amount of expenditure on first commodity and this amount of expenditure on second commodity. So ultimately, this is the total expenditure on optimal bundle, which is be equal to my money income. This is the Wallace law. In other words, we can say the optimal solution occurs at the budget constraint, on the budget constraint, not below. This is Wallace law. Second, budget share identity. इनफैक्ट ଏଇ ଭଲ ସ୍ଲୋରୁ ହିଁ ସେୟାର ଆଇଡେଣ୍ଟିଟି ଆଇଛି ଏ କହୁଛି ଦିଟା କମୋଡିଟିରେ ମନି ଇନକମ୍ ସ୍ପେଣ୍ଟ ଦ ସେୟାର ଅଫ ମନି ଇନକମ୍ ସ୍ପେଣ୍ଟ ଅନ୍ ଟୁ କମୋଡିଟି ଆଡ୍ ଅଫ୍ ଇକ୍ୱାଲ ଟୁ 1 budget से okay next continuity. It says, remember, the demand function will be a continuous function if my utility function is continuous and preference are strictly convex. When I say my demand functions are continuous, it simply imply if the prices or in money income change by small amount, then the demand bundle will also change by small amount. It will never happen that for a small change in prices or money income, there will be sudden jump in the quantity demand. In that condition, demand function will not be continuous. Yeah, the continuous demand function it requires that its utility function should be continuous along with its preference should be strictly convex. Okay, this is the continuity property. Then uniqueness property I explain करते यदि preference टा strictly convex होगा unique solution होगा यदि weakly convex होगा multiple optimal solution पाइबा. The property गुड़ाक मन रखिदेबे. तापर एटा होची derivation of CD demand function. ସେଇ ସିଡି ୟୁଟିଲିଟି ଫଙ୍କସନ ଆପଣଙ୍କୁ ପାଇଗଲେ ଦିଆଯାଇଛି ଫର୍ମାଟଟା ତାପରେ ବଜେଟ କନଷ୍ଟାଣ୍ଟ ଲେଖିବେ ଫାର୍ଷ୍ଟ କଣ୍ଡିସନ ଆପ୍ଲାଏ କରିକି ଆପଣ ଏତେ ସଲ୍ୟୁସନ କାଢି ଦେଇ ପାରିବେ. ତ ଏଇ ଡେରିଭେସନଟା ମୁଁ ଛାଡି ଦଉଛି ଆଜି ମୁଁ କରୁଛି ସମସ୍ତେ ଡିରାଇଭ କରିପାରିବେ. ସଲ୍ୟୁସନ ଇଜ ଦିସ୍ x1 star କେତେ କନଜ୍ୟୁମ କରିବି ନା alpha into m by p1 and x2 star equal to 1 minus alpha into m divided by p2. এটা ମୁଁ x1 x2 କଣ୍ଡ ଏବେ ଏବେ in that condition alpha ଆଉ 1 minus alpha କଣ indicate କରନ୍ତି. This is the my optimal solution. This is my optimal bundle for CD utility function. ହେଲା ତାକୁ ଟିକେ ଯଦି ଚେଞ୍ଜେସ୍ କରିଦେବା ଚେଞ୍ଜେସ୍ କଲେ ଆମେ ଏଇଟା ପାଇବା p1 x1 star by m equal to alpha. এটা কোন this is the expenditure p1 into x1 is the expenditure on first commodity. So m divide করলে কম পাইবা the share of money income spent on first commodity, so that is equal to alpha. Similarly 1 minus alpha কোন the share of money income spent on second commodity. Yeah. Okay, এই প্রপার্টি খালি মনে রাখা হচ্ছে আলফা 1 minus alpha কোন ইন্ডিকেট করছি. Demand for good I depends on price of is price and money income. It does not depend on other commodity price. It is derive कर देबे change in x1 with respect to change in p2 अपन 0 पाइबे 0 पाए माने second commodity price change हेले first commodity demand किसी change होउनी. That means two commodity are not related commodity. Related नुहति माने ସେମାନେ neither substitute हेबे nor complement हेबे. and এই 3D production function रे এই dx1 star with respect to p2 पाइले এই value ही पाइबा और dx1 with respect to p1 पाइले जो पाइबा एक देखो तो x1 जो पाइले द सॉल्यूशन x1 से का ऊपर डिपेंड करछि m ऊपर और निज प्राइस ऊपर. सिमिलरली x2 डिपेंड करछि m ऊपर और निज प्राइस p2 ऊपर. আমি একটু ক্লিয়ার হয়ে গেলে টু কমোডিটিজ আর অনরিলেটেড কমোডিটি. তারপরে আমি ইনকম ইলাস্টিসিটি 1 হবো ক্যালকুলেট করিবে. ইনকম ইলাস্টিসিটি কেমতি ক্যালকুলেট করନ୍ତି চেঞ্জ ইন ডিমান্ড परसेंटेज चेंज इन डिमांड ड्यू टू परसेंटेज चेंज इन इनकम. ना काट देबे और पास्ट आगो कोन करबे ना ये डेल्टा x1 विथ रेस्पेक्ट टू अच्छा देइनी. आई थिंक इनकम इलास्टिसिटी आपण माने इजीली जानछथि डिमांड फंक्शन देइछि x1 देइछि तो डेरिवेटिव ऑफ x1 with respect to m करिवे and then into m by x1 ultimately 1 ही पाइबे x1 हो के x2 नियंतो. तो एटी कोची in case of CD utility function or the demand curve Marshallian demand curve derived from CD utility function will have unitary income elasticity. Similarly its own price elasticity is value equal to -1 and cross price elasticity is value equal to 0. Why? Because two commodity are unrelated commodity. They are not related commodity, so their cross price elasticity will be equal to 0. Yeah. This all. ଏତିକି ତିନି ଟାଇପ ଅଫ ୟୁଟିଲିଟି ସରି ଇଲାଷ୍ଟିସିଟି ଆପଣଙ୍କୁ ଦେଖିବାକୁ ପଡିବ. କ୍ଲିୟର. ତ ଆଜି ଏତିକି ଯାଇ ରଖୁଛି. ନେକ୍ସଟ କାଲି କ୍ଲାସରେ ଆମେ ସବଷ୍ଟିଟ୍ୟୁସନ ଇଫେକ୍ଟ ଆଉ ଇନକମ ଇଫେକ୍ଟ ତାର ଡିଟେଲ୍ସରେ ପଢିବା.
ଆଜ୍ଞା.
ଓକେ ମ୍ୟାଡମ.